All right, well, thank you all for coming today, and it's a real pleasure to be speaking here. So speaking of everyone doing different things, I'm going to take you to Mars today. And so in order to do this, I'll just ask you to have your 3D glasses, which are hopefully provided there, at the ready, but I'll tell you when to use them. Don't have to go yet. Okay. So as a planetary scientist, it's my goal to understand the geological history of the planets in our solar system. And I spend a lot of my day looking at pictures of planets. And hopefully the Earth is still the planet that I look at the most on a good day. But I spend a lot of my time looking at this planet, the planet Mars. And Mars is really unique in our solar system for a number of reasons. It's a dynamic planet. It's much colder and more arid than the Earth. But there are winds that blow sand dunes and dust storms around the surface of the planet today. There are channels carved into its surface, which are evidence of rivers that once flowed across the planet billions of years ago when there was liquid water stable. And there's sedimentary rocks that hopefully record clues to what that ancient climate was doing as you laid down layers of sediment over time. And Mars has really captured the imagination of the public and captured the attention of scientists, most importantly because it represents one of our best shots for looking for evidence of life outside of the Earth within our solar system. And there's one other important reason that Mars is so fascinating. If you've seen the movie The Martian recently, Mars is one of the easiest planets to travel to, and the surface conditions are such that you could actually travel there and walk around on the surface with a spacesuit. But you could look at it with your own eyes. So the description of my talk, I'll admit, was a bit of a teaser. I won't be talking about actual humans going to Mars today, although I certainly hope that one day we do send humans to Mars, and there's a lot of really smart people working to make that happen at some time in the future. But for now, that's a goal for the future. Instead, I'll be talking about how we explore the surface of Mars robotically. So I'm a member of NASA's Curiosity rover mission, a science team member. And this is our lovely robot that we use to explore the surface of Mars. And we've been doing that since 2012. And we landed here in a part of Mars called Gale Crater. And you can see these great rocks in the foreground here. And in the background, there's a mountain known as Mount Sharp that I'll talk a little bit about. And that's a really interesting spot. It's about a 5-kilometer high mountain sitting in the middle of this crater, made from top to bottom almost entirely of these layered sedimentary rocks that we hope record information about Mars's changing climate over time and what the ancient surface conditions might have been like and whether they could have been habitable for life to arise. One of the things that I've been really struck by over the past few years of being on this mission and looking at the images of Mars that come down every day from the rover has been the importance of the human experience in order to interpret the rocks that we see. So how we process all that data coming back from the rover's instruments with our own human sensory organs. And so in many ways, actually, the rover is designed to mimic many of the capabilities of a human explorer. So of course, instead of legs, we have wheels here. And instead of a mouth to communicate those science results back to the Earth, we have an antenna. But we do have an arm, only one, with which we can reach out and touch the surface. And we can even use it to take selfies like the one shown here, which is exactly what a human explorer would do. And then we have eyes in the form of cameras. And so I'm going to talk a bit about using those cameras today and how we understand the surface of Mars, a planet tens of millions of kilometers away, through the lens of a robotic camera. So first I want to take you all the way back to 1976. And this is the very first image of the Martian surface returned from the Viking 1 lander. And so before this image was returned to the Earth, all we had was data from telescopes from the Earth or from orbiters hundreds of kilometers in orbit above Mars. And so to get this picture down for the very first time, you can imagine, is a wholly different experience of understanding what Mars is like. You can see a surface that's very similar to what you might see on the Earth here, with fine-grained soil, a couple of loose rocks distributed around the surface. And it looks a lot like something you might see here on this planet. All right, so get your 3D glasses out. I'll take you back to 2016. And here's one of the first images we returned from Curiosity. This is an image taken on the 27th Martian day, or sol of the mission. And what I want you to do is imagine looking down at your feet and seeing this rock, a couple tens of centimeters across, exposed on the surface. What I want you to appreciate is how this color and 3D information helps you experience the rock. And this rock in particular was very important early on in the mission, because you'll see that there are small rounded pebbles and gravels and sand grains that make up that rock. And in fact, that's very similar to what you might see exposed, say, for instance, on the banks of the Delaware River not too far from here, or any small stream on the Earth, rounded pebbles and gravels. And this rock and others like it, as we explored the surface of Mars, gave us very strong evidence that this represents an ancient stream bed of a river that was active billions of years ago on the surface of this planet, and we had liquid flowing water across Gale Crater. And so there's a couple of features here that really bring that experience back to us on Earth, both for the scientists who have to interpret that geology and to communicate those results to all of you members of the public and share the surface of Mars with you. And so again, there's a lot of features that mimic the qualities of our human visual senses. So just like our own eyes, we have 2 cameras on the Mars rover, and those are mounted at a height that's pretty similar. It's about 2 meters off the ground, pretty similar to the view you experience walking around the surface of the planet. And then we have that color information, which is so important, right? So our own cone cells in our eyes, we have 3 cone cells sensitive to red, green, and blue light. And to mimic that, we have color filters on our cameras that are sensitive to red, green, and blue light to bring that realistic color back to us on the Earth. And it's been really interesting to experience that although we have tons of other science instruments, we have even a number of additional color filters that can sense out into the infrared beyond what our own eyes can see. But those 3 colors, which have been present on every single mission sent to the surface of Mars to date, and many other planetary missions to other bodies, the red, green, and blue, is how we process that visual information, and it's so important in order to understand what that place is really like. And we can play one other trick here. So now this is one of my favorite images of Gale Crater to date. This is now Mount Sharp in higher resolution. You can see these beautiful layered rocks exposed in the foothills here. And you'll notice that the sky is blue in this image, rather than the typical pinkish, dusty sky of Mars. And what we've done here is actually alter the white balance of the image in order to replicate what these rocks would look like under Earth illumination, because that's where we've calibrated all of our geological knowledge over years of wandering around deserts on the Earth. And this is what those rocks would look like calibrated to our own visual systems. Okay, so you can put the 3D glasses back on. And again, this is one of my favorite images. What you'll see here, you can see some detail using the 3-dimensional imaging system, now only in black and white. And what you can see here are ridges of sandstones, very similar to what you might see in the desert southwest in the US, sloping away from the camera here up towards the foothills of Mount Sharp off in the distance. And part of my scientific interest on the mission is understanding what the 3-dimensional relationships of these rocks can tell us about the ancient climate, how water was moving around, depositing that sediment, and leaving it on the surface. And here's one other image again in 3D. We're looking up at a rock here now on the 855th day of the mission. We're on about 1550 or so now. And we're looking up at, again, a view of layers that are hopefully recording information about those ancient surface conditions on Mars that we're trying to read layer by layer to understand what that planet was like, whether it was habitable, and whether the conditions were ever right for life to arise. And so here we are with Curiosity. This is still in 3D, and now this is from overhead, looking down at our little rover there, which you can see. This is a very high resolution image taken from orbit. And we're continuing to explore the Martian surface, driving around from outcrop to outcrop. But now looking back at this image, I hope you can understand the importance of having those eyes on the ground and the difference in the experience it gives you in understanding the surface of Mars. So I'll leave you with two thoughts. First, I want to say that I think we will send humans to Mars one day, even though we have fantastic rovers that are able to do incredible things on the surface of Mars. I think if you can imagine, just from your own experience, a postcard simply will never be good enough to translate the information of a place. A picture of the Grand Canyon can never replicate the experience of going there, standing on the rim, and looking down into that chasm, right? And so for Mars, having robots will never satisfy our curiosity to go there and see it with our own eyes. And second, I want to say that this importance of the human experience and our human sensory experience is in no way limited to exploring Mars. This is important in your own life as well. And I think, a lot of the division in the world today that we experience derives from a lack of shared human experience. And so what I would encourage you to do is, rather than simply viewing the world through the lens of photographs and articles that you read, to go out and experience the world, meet people, talk to them, share human experiences, and explore this world for yourself. And who knows, if you're really ambitious, we still will need a first human to set foot on Mars and see it with your own eyes. Thank you for having me.